In this presentation, let's look at a way of traversing a binary search tree. The method we show here is known as InOrder Traversal, and we'll understand later why it's called this. Before we get too far, I want to mention that it would be a good idea for you to look at previous videos on binary search trees. If you already have a good understanding of the topic and just want to jump in, that's good too. Now let's look at these two classes that we're using for our binary search tree. We have class tree node, which represents a single tree node. We also have class tree, which provides methods so that the client code can manipulate the tree. It uses pointers to keep track of and manipulate tree nodes. In this video, we're going to add an extra two methods to our tree class. The first of these is a public method, traverse in order. It's the interface method that will be used by the client code. We also have a private helper method, traverse in order, that takes a tree node pointer. This pointer points to the current root node of a tree or a subtree, and we will be calling this recursively. Now let's look at the public interface method, traverse in order. And what's this? It only calls the private helper method. The reason for this is simplicity. We want to simplify things on the client code's end, and this means hiding the fact that we need to pass a pointer to the tree's root node when we want to traverse the tree. Now let's look over at the private method now. This method, traverse in order, is actually an overload of the public method. Now the reason the compiler can distinguish them is because this version takes an extra parameter, a tree node pointer to the root node. Now, and remember, the root node can either be the root node of the entire tree or the root node of a subtree. Whenever in this method, we'll use recursion to move down the left or right subtree. The first step is to check if the node pointer passed in is null. If it's not, we can continue on to step 2. In step 2, we actually move down the left subtree by making a recursive call to this very same method. And this time we pass it the left child. Or more precisely, a pointer to the node's left child. Step 3 is to output the value of the node, as we show here. And this step isn't exactly necessary. You could change this to output it to a file or do something else. In this example, I'm just doing it so that we can see the actual output on the console window. In step 4, we move down the right subtree, and again, we're using recursion, passing in a pointer to the current node's right child. Now, because of recursion, the order in which these steps gets executed, well, it's not as linear as it looks. And to fully understand this, let's look at an example of using the method. We have divided this window into 3 areas. On the leftmost pane, you're going to see a binary search tree. The output will be shown on the bottom of the left pane. On the right pane, we have 3 columns: move left, print node value, and move right. These represent the steps taken by a single call to the private helper method. Now, we start with a call to of course, the private helper method, traverse in order, which starts us over at the root node 8. So we're in the first method call. And the first thing we do is move left, which is move down to root node 4. Move down to node 4. This sets off another call, which will move down to the left subtree, node 2. And then we move left again, which sets off another call. Only this time, there's no node. So immediately, if there's no node, we can return to the previous method that was executing. We then print the value 2, and you can look at the bottom left screen and you'll see the 2. The next step is to move down the right subtree, if there is one. This sets off another method call. And again, there is no node, so automatically we return to the method that set off this method call. And since we're done moving left, printing the value, and moving down the right, we can actually return to the previous method. And this, the second execution of the traverse and order method, prints out the value 4. And again, you can see it in the bottom left screen. And then we move down to node 6, which sets off another call to traverse and order. And on this call, we move left, which again sets off another call. There's no node, so we can return right away. We print the value 6. We move right, which sets off another call. And again, there's no node, so we return to this one. And now that this complete method has finished executing all of its stages, it can return to the previous iteration, so to speak, which set off this one. And since this is the second execution of the private helper method, traverse and order, is finished, we can return to the first call that we started out with. And now we print out the value 8. And as you can see, all the values, because of the way we're going over this tree, they're all getting printed in order. We're not going to show any more about this video, anymore in this video. We're just here to demonstrate how complicated the actual execution of such a method is because of the number of recursive calls. In closing, each time we move left or right, we actually repeat the same traversal method, but we're using a different set of data. Again, moving down left or right simply involves calling the traversal method and passing in the subtree's root node, or null if there is none, in which case, if it's null, the next method call will automatically return to the previous method. If you want to actually see this in action, not from this video, you can actually, of course, type the code into your editor and use the debugger to trace the execution. And this actually will help you understand it way more. Because of how the data items are structured in a binary search tree, namely, the left node is less than the root node, and the right node is greater than the root node, the way the data gets generated when we traverse the tree in this way, all the items get printed out in order, thus the term InOrder Traversal. This concludes the video on InOrder Traversal of a binary search tree. Thanks so much for learning. If you want to contact me either for a tutoring session or for some questions, just email me at sparkprogrammer@gmail.com or concord.spark.tutor@gmail.com.